In the last video, we watched how ions are actually what causes the electrical impulse that we see on the EKG, and the ions are moving in and out of individual heart cells. What we have in front of us here is in green, over to the left, we have the SA node, and it's made up of many cells, and shooting off to the right in green is our Bachmann's bundle that's going to go over to the left atrium. And going down and to the right is our pathway down to the AV node. And there are actually 3 or 4 of these pathways going down to the AV node, and they're called internodal or in between the node pathways. These are strictly conductive tissue. They don't contract. That's why they're in green. All they do is conduct electricity. However, they are touching contractile tissue, and the contractile tissue, the heart muscle, is in red here, and you see individual heart cells in red. So right now we're in a resting state. Nobody is doing anything. We are all polarized with the potassium on the inside and the sodium on the outside. Now to indicate depolarization, I'm going to fill in each individual cell. So let's kind of take it through the process and see what this would look like. And it'll show us a couple of things that we need to keep in mind when we're looking at an EKG. Okay, so we've got a cell over here, and it depolarizes. So we know that the cells around it will also depolarize, and because this is conductive tissue, it's really good at this jumping the gap thing, and a lot of cells touching it depolarize very quickly. In the next step, more depolarize. Now at this point you can see that contractile tissue, the red cells, are touching depolarized cells. So we know they're going to depolarize. What we're going to notice about them is that they do so more slowly. But remember, they're also contracting as well as depolarizing. They will depolarize, they will pass on the depolarization to cells that touch them, but they do so at a slower pace. So I'm going to skip forward now, and we'll see what the next part of the process. So we can see now that the entire SA node has depolarized. It has sent its signal partially down the Bachmann bundle, partially down towards the AV node, and in its wake, the beginning of the depolarization of the contractile tissue is taking place. You can see the green signal is going much faster than the red one. We'll skip ahead to the next part of the process. So now our signal is well on its way to Bachmann's bundle and the AV node. The contractile tissue is beginning to get the signal and spread it out, and we'll go on a little bit further. And here we are with the signal well on its way to Bachmann's bundle, well on its way to the AV node, and the contractile tissue continues to propagate the signal, but at a much slower rate. Here are the key points to keep in mind. Number 1, on the EKG, we are tracking electricity, not contraction. We're actually tracking only the electricity that happens in the green section here, the conductive tissue. What we're hoping, and what usually happens, is that there will be contraction, because without contraction, you don't move blood. But we need to understand there is a difference between contraction and conduction. You've got the signal racing down the green lines towards the left atrium and down to the AV node, and you've got a slow and methodical wave-like contraction, hopefully, happening with the red cells, the myocardial, the heart muscle cells, lagging behind the initial impulse.